Hello, algebra students. Let's start with a simple little example where we identify whether or not terms are like. Remember, we can only add and subtract in algebra with like terms. Like terms have an identical variable portion. And so what we're going to see is the part with the letters will be exactly the same. So directions say indicate if each pair of terms is like or not like. Number 1 says 2x and negative 3x. So again, ignore the numbers. Just look at the variable portion. Ignore the numbers. Just look at the variable portion. See how they're identical? Yeah. So these guys are like. They're both x terms. Now, this is one that tricks a lot of students, 1/2 and negative 4. A lot of students will say, well, one of those is a fraction, one of those is a negative. They can't be like. But guys, these are both what we call constant terms. And you don't have to know that word for the GED necessarily, but you need to know what I'm talking about. Those are just plain old numbers with no variable portion, no letter. And so constants are always like. You might say, I don't know how to combine them. I don't know how to add and subtract them. That's fine. You can do it in your calculator when you encounter them. But if you have plain old numbers, you should be able to combine them. Now, this next one, though, on the other hand, we do have a constant, 3. But take a look at this. This is a variable term. This is 3x. So that's an x term and a constant term. They are not going to be like. You can only add constants with other constants. So plain old numbers with plain old numbers. And x terms with other x terms. Wonderful. Next one throws a lot of students because they don't see a number out front of the m, and that's okay. It doesn't matter if you see a number out front of the m there. It is still an m term, and this is still an m term, and therefore those guys are like. Now, of course, if this is an x term and this is a y term, we are unlike or not like. Oh, my directions said not like. I'm fired. And so, yeah, different variables means not like. Now, this is another one. Star this, highlight this, students struggle. If this is an x and this is an x squared, the entire variable portion, including any exponents on the variable, have to be identical. If they're not, this is not like. Just like 3 and 3 squared are not the same number, x and x squared are not the same number. All right, so 4y squared and negative y squared might look funny, but they both have an identical variable portion, the y squared, so they're like. Then again, we have one where it's a variable term k and a constant term, no letter, so these are not like. And again, I don't care if it's decimals out front, fractions out front, if the variable portion is the same, they are like. And if it were to freak you out on the test with decimals and fractions, you would just pick up your calculator anyway. Now, be careful of double variables. Yes, these both have a y, but the entire variable portion needs to be identical. Xy's are not the same as y's. These are not like. And then same thing when those exponents travel. Watch out. X squared y is not the same as xy squared. That whole big ugly variable portion has to be identical. This guy's not like either. But compare that to 12. This is m n squared, and this is also m n squared. These two terms, they are like. The exponent is on the same variable there. Woo! Nice job, guys. Super proud of you. Happy learning.